form a times 10 to the power of b, where b is an integer, so a normal exponent, like 1, 2, 3, 4, negative 1, 2, 3, 4, or 0. And a is between 1 and 10. What two numbers is a between, Katie?
1 and
1 and 10. Let's write that down, please. Okay. A is between 1 and 10. That means that there's exactly one non-zero digit before the decimal. Now this notation is especially useful for numbers that are either very small. Okay, I'm going to have you wait till our time. I'm going to have you wait till one of them's back now. Okay, or very large. Okay, it's especially helpful for numbers that are either very small or very large, one or the other. Okay, it's really helpful for that. A lot of times we see this in what subject? Any guesses? That's even based on the name. Science, right? It's called scientific notation. So a lot of times we see this in science because we have measurements that are really, really big or really, really small. Okay? So a lot of times we end up seeing this in science. Okay? But it's based upon the math concepts of how it ends up being really big or really small, but we write it differently to where it doesn't look huge or really tiny. Okay? Now notation. What word do you think of when you hear that first part of notation? No. Okay, what about a little bit more than that? Just a little bit more than the no. Note. What are notes? Things that you take and you write. You write. Those are those things you write. Okay. You can write notes in meetings. You can write notes just in life. You can write notes on what you're thinking. You can write notes in class. There's all sorts of places you can write notes. So notation. This has to deal with how do you write something. Notation just means it's how it's written. Okay? So scientific notation, we're just saying, how do we write numbers that are really big, really small, typically for the purpose of science? How do we write them? That's what this is actually saying. Okay? So if I have 1.07 times 10 to the power of 4, 10 to the fourth, okay? So why do we have that? What would be a better way to go about that?
I should also,
Yeah.
I text my mom real quick.
Oh, okay. Yeah, you may text her real quick. Okay, but then let's put it to the side up after that. Okay. Thank you. Okay. I appreciate you practicing that too. Okay. So 1.07. You guys don't have to write this part down. I want you guys to see it. I want you guys to visualize this right now with me. 1.7 times 10 to the fourth. Okay. Now, what is 10 to the fourth? Well, who do I not know? 10 to the power of 4 is how many 10s being multiplied together?
4.
4 of them. Very good. That's 10 times 10 times 10 times 10. Now, do you guys know the trick with multiplying powers of 10 or multiplying multiple 10s together? What is it?
So you just add the 0, add a 0.
Yeah, you keep the 1 in front and you add the number of zeros. This is a 1 with how many zeros?
1,000.
It's a 1 with how many zeros?
1, 2, 3, 4.
4.
Yeah, 1,000.
Nope.
Oh, it's 10.
10,000. Okay. That's why it's better just go out through and count the zeros and go. Literally just go 1, 2, 3, 4. Oh, it's 10,000. Okay. So it ends up being 1.07 times 10,000. Okay. 1.07 times 10 to the fourth ends up being 1.07 times 10,000. Okay. So all of a sudden, can we already start to see why this number might get really big? Because we're multiplying by 10,000 instead of just 10. So now let's figure out what this actually is. 1.07 times 10,000. If I do this work off to the side over here, okay. When we're multiplying, we kind of ignore the decimal for a moment, and then we put it back in at the end. Okay? And I'll go discuss that a little bit here. Well, hey, what's 0 times 7?
0.
And what's 0 times 0?
0.
What's 0 times 1?
0.
Okay, so it's just going to end up being 0, right? Is the same thing going to happen with this 0? No? Yeah, is the same thing going to happen with this 0? Same thing going to happen with this 0? So how many zeros are we just going to have here? 4. Okay. So now for real, let's do 1 times everything. Okay, those can just end up being placeholders. What's 1 times 7?
7.
What's 1 times 0?
0.
What's 1 times 1? Now, in total, after we're done multiplying those, in total, how many numbers do we have after the decimal before we started? Hey, how many numbers do we have in total behind the decimal when we started?
All of them.
Do we see any numbers behind a decimal here?
No.
Do we see any numbers behind a decimal here?
Yeah.
How many?
2.
So in total, how many do we have behind the decimal?
1.
2. That means in total we need the same number here. 2 behind the decimal. So I put it with 2 numbers behind it.
Okay.
So this ends up being 10,700. And do I really need to put that 0.00? Do we need 0.00?
Nope.
No, it's not. Okay. If there's $1, we don't need to say it's $1.00. If you say $1, we know you mean 0 cents. Okay. Same idea. 10,700. We don't need 10,700 and 0, 0. Now, Brady, you just have a moment to be on that and move out of the restroom along
Oh
right
yeah, I know. I just have to change this.
That's what we should be listening to music during notes. Hey Brady, can you take that out? It just said we should be listening to music during notes. Okay, thank you, I appreciate that. Okay. So, we end up getting 10,700 here. Now let's try and see what 1.07 times 10 to the third would be.
Wait, isn't this just decimal points? Like we're
We'll get into that. We're doing our discovery first. I don't want you guys just, because I don't want you guys just to know, here's the fact. I want you guys to know why. Because at the end of the day, with all of the math, there's some of it you're going to use in your daily life, and there's some of it you won't. Like, we don't exactly know. We don't exactly know which part of it you're going to use and which part you're not, because that depends on your career, your life, what's going to happen. We don't know that yet. But what I can teach you that you can hold on to is these thinking
I got a
skills,
question.
these critical thinking skills, and this problem-solving aspect that comes with math. So that's what I'm trying to help you guys go through with these explorations and understanding why is it this way, and start understanding how things work and why things work, and to kind of work that process. Great question, though. Yeah, great.
Alright, so I might be an electrician or a mechanic. Do you think any of this will be relevant?
I think there's a really good chance, yeah. I think this especially is something that could be very relevant to being an electrician or a mechanic.
To you, let's
Yeah.
teach me good stuff.
Yeah, thanks for asking that. I can really see this being handy. Okay, 1.07 times 10 to the third. Okay, well 10 to the third is how many 10s being multiplied together? Yeah, Okay. Is 10 to the third is how many 10s being multiplied together?
3.
3. Now, Katie, you said our trick with 10s was a 1 with how many zeros behind it here? 3. So it ends up being, this number ends up being what? 1,000. That's 1,000 you're looking for earlier. So we end up having 1.07 times 1,000. Before we had times 10,000. Let's go over here and do that math. 1.07 times 1,000. Now once again, when we multiply, we can ignore the decimal at first.
So 3 zeros.
Okay? We're going to have those 3 zeros there just as placeholders. And now we actually start with the real actual. 1 times 7. Okay, 1 times 0. Oh, it's 1 times 1. Now how many numbers do we have to put behind the decimal? 2, because we had 2 before it. So it ends up being 1,070. Very good. And we don't need, okay, that 0.00 at the end. Okay, it's just not necessary. Okay. So once again, this number ended up getting a lot bigger than what it started with at 1.07, didn't it?
Yes.
Okay, just like in the green. Okay, let's look at this one here in purple. If I do 1.07 times 10 squared, okay, 10 squared is what number, guys?
10,000? No, 100.
100. It's a 1 with 2 zeros behind it. 10 to the fourth ended up being a 1 with 4 zeros behind it. 10 to the third ended up being a 1 with 3 zeros behind it. 10 to the second is 10 with 1 with 2 zeros behind it.
Thank you very
So it's
much.
1.07 times 1,000. So you can do that off to the side here. How many zeros are we just going to end up having to write there as placeholder? 2. Because 0 times all this is 0. 0 times all of this is 0. Think of it, Harrison. What's 1 times 7? This is-
7.
7. What's 1 times 0?
0.
What's 1 times 1?
1.
Now, how many numbers were behind the decimal point to start with?
2.
Well, that's high.
2. How many numbers are behind the
2.
decimal now? 2.
Look at that.
So it ends up being 107. So the number still got bigger, right? Now,
gross.
That's disgusting. Excuse yourself.
And they,
I didn't excuse you.
Hell no.
They get not on that.
Yeah, there you go. That's better.
No, man.
Let's try not to do this. That can be very rude.
Okay, I didn't know anything about that.
Really, Fossil, you wanna bite this?
No.
Ew. Look at it,
Shoot
it's
it,
falling
Mr.
apart, bro.
Hey guys, let's. You ready to do one question for me? No. Okay, Brady, put it away.
Best catch.
Thank you. Okay, so are the numbers getting as big as we started with?
Probably. It's smaller.
No, they're getting a little smaller. They're still getting big. They're just not getting as big. Okay. Well, let's try. Let's keep one more. Let's do
That's
one more
just
here.
10, bro.
Okay. 1.07 is just 10, isn't it? Okay.
Said 17.
So it ends up being.
17.
Not 17.
I did 70.
7.
1.7.
Straight out. How many zeros do we write down here?
10.7.
One.
10.7.
Okay.
One.
0 times all this?
One.
0. What's 1 times 7?
7.
1 times 0. 1 times 1.
1.
How many numbers behind the decimal?
10.7.
So it is 10.7. Okay, and you end up getting $100 guess.
$10.70.
Kind of, yeah. Okay. So with each of those, our original 1.7, we started off with 1.7 each time, didn't we? Now they all ended up getting bigger, didn't they? Okay. Now, can we see in our answer? Can we still see that 107, 107, 107, and 107 that we started with? Yeah. But what happened to our decimal point? It kept moving. So here, how many spaces did our decimal point move from here to here?
1.
It moved one spot. How many spaces did our decimal point move from here to here?
2.
2. How many decimal places how many
Three.
decimals did it move here? 1, 2, 3, so we had to add a 0 in.
4.
4, so we had to move it, add 2 zeros in. Now, why do we think this one, green up here, moved 4 decimals, whereas orange only moved 1?
It's a very large number.
Okay. It's a very large number. There's that many zeros afterwards when you're multiplying by powers of 0 or powers of 10 by a one with a bunch of zeros behind it. That's how much you move the decimal. So when we have 10 to the 4th in the green, how many spots did we move that decimal? 4. How many spots did we move the blue decimal? 3. 10 to the 3rd. How many spots did we move 10 to the 2nd in purple? 2. How many times did we move 10 to the 1st in orange? 1. Are we noticing a pattern there? So what's this exponent tell us?
Or how many zeros there are, or how
It-
fast it moves.
Okay?
No, where did that one go?
Where the decimal, how far we move the decimal. Here you moved it 1 spot, 2 spots, 3 spots, 4 spots, right, Sierra? Okay, and that tells us how much we move the decimal. Please stop.
That's good.
Thank you. Please stop. Click the pen too, okay? So it tells us how much we move the decimal here. Okay? That's what it's asking, that's what it's telling us to do. Now-
Up there. I heard it.
Imagine you had like a new, like a burn mark of a new.
How many spots do we think we're gonna move the decimal here on the 10 to the 0? None. Okay? Because hey Brady, can you guys miss what the question I just asked here, okay? How many spots do you think how many specifically you guys missed the first time, so I'm asking you guys this time, okay? How many spots do we think we're gonna move it here?
0.
0, okay? Because what is 10 to the power of 0?
10 to the power of 0 is 10. 1. Oh, yeah.
10 to the power of 1 is 10.
Come on.
So what's 1 times anything?
1.
Zero.
What's 1 times anything?
1! The other number!
The other number.
Oh, wait, 1.07.
So we end up moving the decimal 0 spots. It stays the same. Now, let's experiment what we think might happen when we have to the negative exponent. Because
Notice the
notice,
same, just move from the front.
move from the,
decimal
what do you mean
front
move
side
from the, so you move it the other direction? Okay, let's try it out. I like the hypothesis, let's try this thing out.
I'm onto something, boy.
I can't see this.
I don't even know what this
So 10 to the power of negative 1. Well, you said negative exponents means you do what? Send it where? If it's upstairs, where do we send it?
Downstairs.
Downstairs.
There's downstairs.
So it becomes 1 over, goes 1 over
10.
10 to the power of 1, aka just 10. It becomes was just
Okay.
10. Now, do we know what 1 divided by 10 is in decimal form? Let's try it out. How can we figure that out? Well, you can actually take 1 and divide it by 10. A fraction is a division problem.
Yeah.
Okay? So does 10 go into 1 at all?
Yes, sir.
No, it doesn't. So we have to add a decimal and keep going. Does 10 go into 10 though?
Yeah.
Once. So what's this end up being?
0.1.
0.1. So we have 1.07 times 0.1. So notice, did our number we're multiplying by just get a little bit smaller too? Hey, Tony, didn't I ask you to take those out? I super did. You did. Take them out already. Okay, let's keep those out.
Why can't I just keep one so I can see everything?
You're right, you're not seeing it, okay? But I have a feeling that what's happening is it's distracting you as we're going through this. Okay? So that's the rule I've made. Okay? So what happens here is the number we're multiplying by gets smaller every time by a power of 0 as well. We're moving the decimal on that. Okay? So we're gonna take 1.07 and multiply it by 0.1. Brady, hey Brady, hey Brady, I'm asking you a question.
Green, red, yellow.
Brady, Hayden, stop. Brady's trying to ask you.
color flag thing, like, it's like red.
Green, red, yellow.
You're being so disrespectful.
Yeah, okay, it's true. Okay, hey Brady, I'm trying to ask you a question here. Okay, what is 1 times 7?
1 times 7 is
7. Okay. Hayden, what's 1 times 0?
0.
Tony, what's 1 times 1?
1.
1. And we don't even need the 0 at the end here because it's going to be a 0. Now, but I'll write it anyway just because. Now, how many numbers in total do we have behind the decimal?
3.
So how many numbers do we need behind the
3.
decimal? 1, 2, 3. So this ends up being 0.107. So did the decimal end up just moving one more this way?
Yeah.
Yeah, so it just keeps getting smaller. Now what do we think? Well, let's hypothesize here. Let's hypothesize here. What do we think 1.07 times 10 to the negative second will end up?
You're gonna go.
It's gonna be in front of the 0 this time.
It's going to be in front of 0, so we're going to have 0.0107, right?
Yeah. Yep, sir.
And is that what it says here even?
Yep.
Okay. And so we can see this pattern continue on all the way through. And we'd end up being multiplying by 0.01. So a positive exponent makes a number what, guys?
or like
Bigger.
more.
Bigger.
That's
A positive exponent
Yeah.
makes a number bigger. That tells us, hey, we're going to move this decimal to the right. That tells us, hey, we're going to move this decimal to the right, okay? And I actually want you guys to write this part down here, okay? I want you guys to write what I'm writing now.
No way.
Now,
Jose.
okay? So positive exponents,
Positive exponent.
I don't
Make-
know my pencil with.
the number bigger. Positive exponents make the number bigger. Okay?
Bigger. You're not like a color pencil. You're not an art teacher.
Positive exponents make the numbers bigger. What do we think negative exponents do then? What do we say?
You got crayons?
Make them smaller. Negative exponents make, no I know Brady, the number smaller.
Darn it.
You guys just, did you guys sacrifice this one a second?
Yep.
Wait, Mason?
Yeah. So what does the power of 0 do? On March 2nd.
Maybe she
Okay,
went down here.
What does the power of 0
Right
do?
here.
Nothing. So the power of 0 stays the same.
What do you need to raise out?
So 0 exponent
This. This. Right here.
Mark and type one.
Yeah, the one right there. Thanks, man.
Is there a JV as a varsity for
There's varsity today.
soccer?
we don't know for sure yet. We don't know exactly how many boys we're gonna have.
What's in the mental?
Dude, you're gonna have 2 right here. 2 right here.
Oh totally. Hey, we'll see you guys at the meeting tomorrow. Or at school in my room, okay?
I'm
So-
on the way really today.
Same.
I think that's Oscar, dude.
Yeah, there's that.
Hey,
Remember
let's do
what
it
else
during the
going
pass
on.
period, okay?
Good, just like 2 seconds, come on, please.
During pass period.
I just need to spell Waverly.
I don't care right now.
Come on,
Please, hey,
come on.
work with me on this.
Come on, dude. Short with you. I've been working good with you all day.
That's not entirely accurate.
Okay, fine.
Thank you. So, positive exponents, make it bigger. Remove the decimal points that many times. Okay? 0, stay the same. Negatives, make it smaller. Okay. Let's continue on right below this real quick. Okay? Rating. Rating.
Guys, we have 5 minutes.
Oh, sorry, I had to check my phone.
Okay. So we're gonna try and write the following in scientific notation. So we're gonna go from big number or small number to scientific notation. So 52. How many numbers do we want in front of the decimal? Caden, why don't you have that already written down?
Because I had to erase it because I messed up and you're going way too fast.
We're going way too fast.
Because we only have 5 minutes.
Using the following numbers right in scientific notation.
I don't think we're
Everyone
going
just
way
keep
too
talking,
fast.
you know what I mean?
I think we might just not have been paying close attention.
Give it.
So
Give it.
52. How many numbers do we want to be in front of the decimal if we have scientific notation?
1,
One number in front of the decimal. How many number? Where's the decimal secretly at right now? 52.
Oh,
Point
Minus the
0.
2.
Yep.
So it's secretly 52.0. But do we want the decimal where?
No.
That way.
We want it this way. How many spots do we want to move it this way?
2.
1.
1. We want it between the 5 and the 2. We want 5.2. So we call it 5.2. Is 5.2 the same as 52?
Yeah.
No. So we have to do is did we make this number bigger or smaller? Smaller. So what we have to do is we have to make it times 10 to the positive first. We have to make the exponent bigger. We have to make it times 10 to the first. Because how many spots did we move the decimal? How many spots did we move the decimal?
1.
1. And put it away, please.
Okay.
Seriously, you and Brady were so close to having that taken me off this. Okay, you guys have both been on a lot today, and I've asked you guys so many times to put it on.
Thank you very much. You're welcome, man.
So, we made the exponent bigger because the number got smaller. Now we have 5.2 times 10 to the first, and this is in scientific notation, which is what we were asked to do. Okay?
That's all you got, right?
Can I have you guys try number 2? Can I have you guys try number 2 on your own?
Oh, man. Okay. This one's different. This one's harder.
So
It's a little
even,
different. Same idea.
even since this has that little comma, that doesn't mean nothing. We still like put the decimal right then.
Correct, yep.
And we just want to go for 1.
We want it to where there's only one number in front of this.
Oh, okay. It's easy. I got you.
Oh, no, it's 2.
Got it. You want to see it?
It's here, it's always only one number.
Let's see.
Which is why we would open up 4. Yep.
So that's right.
Yeah, that's where you want the decimal. Okay. So let's talk about this one up here, guys.
Huh?
So 8,452. Where is our decimal right now?
It's behind.
Behind the 2. Where do we want our decimal to end up? Between what 2 numbers? 8 and 4. We want one number in front of the decimal and one number only. So how many spots do we have to move it to get it in front? Between 1, 2, 3. Kane's right. So it becomes 8.452. 8.452 times 10 to the third. So did I make my normal number bigger or smaller?
Smaller.
Smaller. So I have to make my exponent bigger by 3. So because I moved it 3 decimal places, I had to make this number bigger by 3. Okay? I want you guys to try number 3 as well here. Okay? I want you guys to try number 3 as well here.
Number what the? Is that?
Okay, calm down.
With the following conditions, please come to the office after the bell.
Mr. Cossel, is this correct?
See if you're okay. So the decimals after the zero, where do we want it between what two numbers? The 2 and 4. So you have to move it 1, 2, 3, 4, 5, 6, 7, 8. Get there. 2.48, 3, 1, 2, 4, 5, 0. We want all those written times 10 to the 8th. Once you have that written down, you guys may pack up.
Okay, I got it right.
So,
Yeah, I got it right before you though, so.
Yeah, me too. I got an extra for kids.
hey, listen up. Next. Hey, listen up. Listen up. Listen up. Yes. Next time, okay, what's gonna happen is, finish